All right, algebra students, I'm going to do 3 more examples. Some feedback that Ms. Lovesock and I got was, firstly, you wanted like shorter videos, and the second was more examples. We're trying to combine that, where I'm going to split it up into 2 shorter videos with a lot more examples and maybe going a little bit faster. So here, are they like terms? No, they're not. They're not like terms. If you were to look at this, hopefully you were like, I just can't like combine them. It's not the square root of whatever, like 25. I can't do that. But what I can do is simplify both of these and see if the simplified version can be combined. So what perfect square, if any, goes into 45? 4 doesn't, 16 doesn't, 25 doesn't, 36 doesn't, but 9 does. And so the square root of 9 and the square root of 5 is what goes in, because 9 times 5 is 45. Now the reason I pick a perfect square is because the square root of 9 is 3. So far so good. I simplified it. Let's see if I can combine it with whatever is over here. So we're going to subtract the square root of 20. Well, the square root of 20 can be simplified. That would be 4 and 5. And the reason I picked 4, the reason I picked 9, is because I can simplify those to be a whole number. Can I combine them? Yes, they are like terms, so I'm able to combine those. They're 3 roots of 5 minus 2 roots of 5, or 3 apples minus 2 apples is 1 apple. So good to go. You could also write it like this. You wouldn't have to have that coefficient of 1. We're just rolling. We're going to keep going. Another example. 5 roots of 27 plus 3 roots of 12. This one only looks different because there's numbers out in front, but we're just gonna keep going. I know that we can do this together, so let's see what this is gonna look like. Firstly, can I combine those? Are they like terms? No, like I can't just add those up and pretend that it's something it's not. But I can simplify both of those, and we're gonna simplify them. What perfect square goes into 27? 4 doesn't. 9 does, and I can keep going. 16 doesn't, 25 doesn't. So it's 9 and 3. Now here's the deal. That 5 just gets brought down. He's still there. He's still important. We do want to bring him down, but we're not going to do anything with him just yet. And at this point, we want the square root of 12 to be separated out. Again, just like the 5, the 3 comes down. The 3 hasn't changed. Just leave him there. But the square root of 12 and the square root of 12 simplifies to be the square root of 4 and the square root of 3. And we like 4 and we like 9 because we can simplify those. Let's go another step. This is like individual little multiplication symbols. So 5 times the square root of 9 is actually 5 times 3. Because that 9 turns into a 3. Same thing over here. 3 times the square root of 4 is actually 3 times 2. Because the square root of 4 is actually 2. We're almost done. We're getting closer. I can multiply those coefficients out in front. 5 and 3 is 15. 3 and 2 is 6. And I want to add up those terms there. Can I combine those like terms? Yes, I can. They're like terms. I have a square root of 3 and a square root of 3, and I can add those up. If I have 15 roots of 3 and 6 roots of 3, I can combine those, and I have 15 plus 6, which is 21 roots of 3.